right, if we're ready online and everybody in the room, welcome to the Garrison. For those of you who have never been out here, we've got a great facility. Is one of our flagships, I would call it, of the Indiana State Park system, and so very welcome to be here. I'm glad you're here, and I'm sure we're going to have a great meeting. I'm Alan Morrison. I'm the Director of Natural Resources here in Indiana, if you don't mind, we'll just start over here with Representative Lopez, and we'll go around and introduce ourselves, who you're with, and then we'll get rolling on the meeting.
Danny Lopez, I represent House District 39, which is the east side of Carmel and the west.
Good afternoon, everybody. I'm Todd Thompson. I'm the director of the Indiana Geological and Water Survey and the State Geologist of Indiana.
I'm Terry Morrison. I'm with Alliance Resource Partners.
I'm Greg Good, State Senator for District 38, Vigo, Clay, and a portion of Sullivan counties.
I'm Megan Savage. I'm the VP of External Affairs at the Heritage Group.
Hello, everyone. I'm Andrew Pappas, Deputy Assistant Commissioner for Office of Land Quality with the Department of Environmental Management, here for Clint Woods today.
Hi, everybody. Mike Woods at Woods Capital. I'm an investment bank, originally from Indiana, now live in New York.
Eli Eckhart with the Indiana's Commerce Vertical and the Indiana Economic Development Corporation.
Well, thank you all very much for being here, and we do have a quorum, which is great. I don't believe we'll be voting on anything today, but it's nice that we had everybody here show up, so thank you. And of course, we have the woods next to each other, which is always good. I'd like to start off by kind of reminding everybody here and online why we're here before we get started with our agenda. Executive Order 25-62 was signed by Governor Braun, and there's quite a bit to it, but let me just remind everybody a couple of points. In a 2022 U.S. Department of Energy report to Congress entitled Recovery of Rare Earth Elements and Critical Materials from Coal and Coal Byproducts, the United States government demonstrated the ability to recover rare earth elements and critical materials from coal and coal byproducts. Rare earth elements and critical materials form the backbone of modern technology, powering innovations across industries, including energy components, advanced batteries, wind turbines, aerospace technologies, communication systems, and defense applications critical to national security. China dominates global production, refining 30 of the 55 critical minerals, processing 90% of rare earth elements, and commanding 60 to 70% of lithium and cobalt supplies, posing challenges to United States manufacturing and energy independence. The United States needs a domestic supply for rare earth elements and critical materials for manufacturing essential technologies. Indiana possesses vast underutilized reserves of legacy coal byproducts, which, if responsibly remediated, could serve as a valuable domestic feedstock for the production of critical materials, advancing national security, energy independence, and cutting-edge manufacturing capabilities. The Rare Earth Recovery Council was established to do the following: advance the development of an innovative, environmentally sustainable coal site reclamation and cleanup program for existing and abandoned mine sites, actively collaborate with industry partners to deploy cutting-edge technology in Indiana to recover and refine rare earth elements and critical materials for reuse, evaluate the potential for localized and/or regional refining operations for creating a pipeline for industrial-grade materials and economic development, establish an Indiana-based supply process to unlock coal waste as a strategic feedstock for rare earth elements and other critical materials, ensuring their availability for use in domestic technology manufacturing, and finally, collaborate with Indiana universities and educational institutions to create a workforce development program aimed at equipping graduates with the technical skills necessary to support advanced mineral recovery and processing efforts. So I'd also like to give a thank you to my Chief of Staff, Maddie Connor. Maddie has been really the tip of the spear for this commission and for this EO. that was signed by Governor Braun, and she has brought everybody here today and has organized everything. So Maddie, thank you very much for all your hard work. So if we have anybody have any questions or comments on anything? No? Okay, then we'll go ahead and get started. And our first presenter is Anthony Rogers with Cerba Solutions, and he is one of the largest battery recycler in the United States. And Mr. Rogers, the floor is yours.
There we go. Excellent. Thanks for having me. I'm happy to be here. I'm with Cerba Solutions, which is circular battery solutions all across North America. You can see the locations up there. We are a diversified, complete battery management and solutions company specializing in the logistics, collection, sorting, and processing and recovery of critical minerals and putting those back into the battery supply chain. I'm a chemical engineer from Purdue, so I'm born and raised in Indiana, so good to be here and part of the Indiana government structure and things. Chemical engineer, vice president of technology for the company. Actually worked at the Heritage Group prior to the formation of Cerba Solutions, which has some legacy heritage entities involved in it. Here's a quick look at our locations on the map. Over 35 years of recycling experience across some of our legacy companies, Retrieve Technologies and Battery Solutions. Handle all different battery formats. We specialize in lithium ion as that's the new kind of growing chemistry trend, but I think we handle over 50 million pounds of lead acid as well. NiCad, nickel metal hydride, alkaline batteries, lithium primary. So we see all the different form factors from little button cells all the way up to lithium ion bus batteries and energy storage, grid scale energy storage. We do all in-house shredding and processing for most of those chemistries. There's a few that we just broker. And then we have finalized the engineering design package for a hydrometallurgical processing approach to further kind of onshore the refining and recovery of those critical minerals, lithium, nickel, cobalt, and manganese to put directly back into the battery supply chain as opposed to just producing the crudely named black mass or intermediate kind of concentrate product that we produce today. Some of the other, we do a lot of project management for battery changeouts at cell installations, telecoms, all the different places, as well as storage, diagnostic, repair, and processing. So try to be as full service to our partners as we possibly can be. I'll go through this so we can get to the good stuff. We are actively scaling through some of the DOE grants over the past 3 or 4 years. We've invested over $200 million over the past 3 to rapidly expand our shredding and processing capability to be able to kind of meet demand for the ever-increasing end-of-life and production scrap that's associated with the new electrification and build-out of the new EVs as well as the energy storage market. We're up to roughly 35 to 50 thousand tons a year of lithium-ion processing capabilities, as well as smaller volumes for alkaline, lead acid, nickel metal hydride. So get to more of the technology part, since that's why we're here to talk about kind of critical minerals. So for everyone who's not aware, this is kind of the generic slide of a lithium-ion battery where you have a cathode and an anode. Cathode is an aluminum kind of foil with the lithium metal oxide coating, which is where all of the critical minerals reside in the battery. You have a plastic separator, an anode, which is copper foil, which has become very important from a critical mineral standpoint, as we've seen with the high prices lately. And then typically a carbon or a graphite active material coating. As you charge and discharge, those lithium ions pass back and forth between the 2 phases in an electrolyte solution, which is allowing you to store and then discharge energy as you need it. Why is that important? So here's the actual inside of a lithium-ion battery, so you can see what those pieces look like instead of just a nice animatronic approximation. See a thin film as the separator, shiny aluminum with a dark black coating for the cathode, and then the copper foil coated in the anode. So at CERBA, well, I guess a little bit more about the background, and then I'll show pictures of what we actually produce and how we do it. Here you can see you hear a lot of numbers about lithium and nickel, and what does that mean? Well, here's an EV battery cell that is the building block of a large-scale electric vehicle battery pack. It's 1.3 kilograms that gets added in series and parallel to get the desired voltage and total energy. You hear some, like the Lightning and the GM Hummer can power your house for 4 or 5 days because they're over 100 kilowatt hours, and then you have some hybrid packs that allow you to do start-stop and save a little bit of fuel. That can be a couple kilowatt hours. So mild to wild as it gets in the EV industry space, and the number of those cells that you need to package together to achieve the desired energy content. It's about 3% lithium and 20% nickel and 1% cobalt. And so as you continue to package those together with additional wiring harnesses and packaging material, those concentrations continue to go down. So here's the module, which is kind of the next building block with the cells. Helps with repairability from an EV pack perspective. So if one cell fails, you can take it into the dealership. They can remove that module, put a new module in, and put you back on the road. And then finally, at the pack level, so this is an 85 kilowatt hour pack, which would be kind of a full-scale electric vehicle, like a Chevy Bolt or E-Mustang or one of those type equivalents. Weighs about 1,200 pounds, and at that point it's down to less than 2% lithium by weight. So still quite a bit higher concentration than coal fly ash, but there's still a lot of other ancillary materials that you're dealing with as a recycler. Here's a rendering of one of our new shredding and processing lines that can handle 15 to 20,000 tons a year. We have an in-feed system there on the far right, and then it goes through multiple shredding and milling stages to pulverize those materials down and separate through separation steps at the back so that we can recover that lithiated mixed metal oxide, which is where the nickel, cobalt, manganese, and lithium resides, as well as metallic concentrates of steel, copper, aluminum, to put those back into the recycling industry. There's a little bit of glare, but here's essentially the three products we produce from those complex different forms of batteries that I showed. The black mass, sadly it's a really bad industry term that's just generic, but it works. On the left, which is where the graphite and the cathode active material reside. At the top is the metal concentrate with the copper and aluminum, and then the plastic separator material, some of the pouch materials, tapes, foams, and other kind of ancillary cell and module components reside. Pause real quick. I've been covering a lot. I don't know if anybody has any questions, or I can keep plowing. Okay. So, as much as we all like to recycle for the right reasons, we know that economics have to be there for this to really drive forward. So here's a quick snapshot just to kind of level set everybody on the scale of the battery recycling initiatives. Data's a little old, but if you take the number of EVs that are on the road as of 2023 and the number that were sold that year of 1.1 and 3.6 million pounds, take that average composition from the EV pack that I showed earlier and do all of the math, it works out to about $2 billion worth of critical minerals at that 1.1 million electric vehicles per year that's deployed into the US economy. Total of on the road as of 2023 was $6.3 billion worth of just lithium, nickel, cobalt, and copper. And so as that deployment and adoption rate continues to ramp and the on-road inventory continues to grow, that number continues to build. Doesn't include outdoor power equipment, which is very fastly growing market with blowers, weed eaters, snow blowers, lawn mowers, and then energy storage, which is very high volume as well. So it's a very fastly growing, large value market that we want to keep out of the landfills and try to get as circular as possible.
So with all of these batteries being sold and deployed, obviously at some point they run their life cycle. And so could you explain real quick the process of, you brought up like the Lightning and the Ford Lightning, right? When that battery is done and you take it in, I can't imagine what the cost is on that to replace that battery, but what happens to that battery from there until it gets to you?
Sure. So it can take a few different pathways. Sometimes if it's under warranty or if there's some kind of repair that's happening, we work directly with dealerships on a return program or recycling program via the parent organization. So let's use Ford, for instance. If somebody takes a Lightning in and gets it repaired under warranty, Ford actually owns that battery. And so we have contractual rates and logistics set up. The dealership will call, we'll send them a returnable dunnage type crate or packaging, and then send them. Sometimes for some customers, we manage their refurbished packs that we'll send back to be replaced. Other times it'll just be a one-way transaction. We work with the large auto recyclers, so like the LKQs and other kind of people who will buy wholesale vehicles at auction and piece parted out. And then also with the end kind of prior to shredders, the next step after the pull apart type companies who have to remove the batteries before they shred the chassis, because obviously it can be pretty 4th of July-esque if not. So it can come through a lot of, we are seeing a lot of EVs leaving the country as a used vehicle and going to various different overseas markets where they don't have new EV sales. You don't pay the tariffs and other things on used vehicles like you do on new. So there are a lot of packs that don't actually end up with us that leave. And then there's a small subset of Second Life with people taking gently used EV packs and combining them together for energy storage, typically at like a smaller home residential or small off-grid type scale. Yeah. That's the last I had. I didn't want to overshoot my 20 minutes, but happy to talk about any of the pieces of lithium-ion battery or other battery recycling if any questions.
So on, you're getting your feedstock from OEMs. Are the OEMs also taking your offtake, or are you selling that to traders, or both?
A little bit of both. Mostly the OEMs haven't got sophisticated enough to fully touch all the pieces of their supply chain to orchestrate, just because it has to go through so many steps to get back into their batteries. They're hoping to do that. They're starting to do trials and kind of put the pieces together, but mostly it's a buy-sell transaction with different buyers and sellers.
And can you talk a little bit about what you're doing with the graphite? Oh, sorry. There we go. And can you talk a little bit about what you're doing with the graphite?
Sure. So as part of the hydrometallurgical process development and piloting, we've generated a lot of samples of after you leach all the metals out, you're left with the graphite type residue, some binders and other material. But we worked with a lot of national labs and universities as well as graphite manufacturers. And why there's a few promising pathways, there's no definitive commercial scale cost-effective pathways to get that material back into batteries. The blend of synthetic and natural flake graphite, whenever it goes through the milling and mechanical processing and then subsequent leaching steps, breaks down the morphology or the structure, so it has to be re-spheritized. And then you also add a lot of impurities that can be pretty costly to remove. So at this point, I wouldn't say there's a commercial scale cost-effective way to get that back. We have looked at lower scale like electrodes and other things not in the battery supply chain that are promising, but sadly haven't seen anything super promising from a battery grade feedstock.
But the other 4 components you pull out are battery grade once you recycle them out?
From our downstreams, they all get back in. Well, the copper goes through a tradition. Some of them go into big buckets that it's hard to say exactly where they're going. Like the copper could go back into wiring, or whether it gets back to anode grade current collector quality. hard to know. But all of the lithium, nickel, and cobalt definitely go back into battery materials.
And is your business model to protect our supply chain here in the United States, to keep everything here, not shipping that battery grade material back to China to create black mass, or is it being created here?
So sadly, there's no domestic PCAM and cathode manufacturing. So there's no domestic consumers in the battery supply chain in North America. So we have to ship them overseas to be able to put back into batteries. We'd love to keep it in North America, but the battery supply chain hasn't fully, we've started at the cell level and it hasn't worked its way all the way back to the PCAM and cathode manufacturing steps.
Yeah. Thank you.
Yep.
For somebody that's not as technical on, educated on this, so if 1,000 batteries were to come in and go through your process, when you, the product that you have afterwards, how many batteries can that produce then? Like, what can it go into, if that makes any sense? And I know it's probably not that easy, but.
No, it is. I mean, I would say there's probably a 5 to 10% loss, or for every pound of lithium that comes in, 90%, 95% is going back to a refiner who can put it back in. Some of it's lost to the different streams. You don't get 100% separation efficiency. So it's really if you have 100 kilowatt hours that comes in, call it 90 to 95 kilowatt hours worth of raw materials going out. And most of the batteries we receive, except for manufacturing scrap, are older generation batteries that don't have the same energy density or the same cutting edge cathode technology. So in some cases, you may even overcome those losses just because the technology's increased so much from the early stage batteries that aren't as efficient that we're receiving. Hard to say for sure. I would say it's probably conservatively, there's probably a 5 to 10% loss.
Well, great. Any other questions?
I have another question.
Yep.
Sorry, I'm geeking out a little bit on
No,
this
you're
one.
good. No.
Now, your equipment that you're using and building for the line that you're doing the recycling, is that predominantly off-the-shelf equipment, or is it custom-made at all?
So the parts are, I would say, off the shelf, like the individual shredders, hammer mills, filter press, those types of things are all kind of off the shelf, but the design is our company's 4th generation. So we've iterated over the past 15, 20 years and increased size and kind of modified things to improve recovery, improve offerability. So it's our custom design, but using kind of off-the-shelf pieces.
And has your dominance in the U.S. been made through some kind of patent or special IP that you have within your multiple stage cycle of the recycling?
I would say it's just trial and error know-how. I mean, by being in the battery industry for over 35 years, you learn things a lot of times the hard way, which isn't always ideal, but by learning things the hard way, you can kind of optimize and grow and not repeat those. And it's a tough business. I mean, it's like specialty chemicals / glorified scrap yards. I mean, the inputs and outputs and economics of it are pretty challenging. So a lot of it's just the history and the legacy that we've learned over the years, I would say.
And your off-the-shelf component parts, are they American-made or foreign?
They are.
Good.
Yep. Everything through the grants had the Made in America requirement. So plus it makes sourcing and reliability a lot easier than buying from overseas without. Some things are we buy a few things from Germany and a few other kind of specialty manufacturers, but I would say 90+% is made in America.
My last question, how much are you working with Indiana companies?
The Heritage Group is our parent company, so we try to do as much. There's 3 cell manufacturers that we work with from an offtake perspective, and a few solvent recyclers, refiners that we're doing some trials with right now.
Okay. Thank you.
Yeah.
All right. Anyone else?
Yeah.
Yeah.
One quick
Great,
question. I did notice on your map you guys are operational in U.S. and Canada. So, in your experience, the compliance and permitting differences, U.S. Canada, state to state, and then are there opportunities or are there challenges that your organization or your market is facing?
Definitely. vast, I would say, differences state to state, country to country. I would say Canada is a little bit more restrictive than some of that's legacy. I mean, our Lancaster, Ohio facility is a RCRA TSDF Part B, permitted hazardous waste treatment facility, due to the legacy lead acid and NiCad batteries. So that makes our lives a lot easier than people who try to operate under the universal waste and CCP kind of frontier, I guess I'll put it that way, because we're able to store and process and treat a much wider range of things instead of just what falls under those two categories. State to state, we do see very large I mean, looking at actively permitting a South Carolina facility versus, again, the TSDF for us is a big differentiator. It's not going to say impossible to get another one, but it's a very time-consuming, very costly thing, so it gives us a lot of operational flexibility, whereas trying to get one from scratch could be a 2 to 3 to 4 year process with public review periods and a lot more questions and scrutiny. So I think the biggest thing that's the industry is kind of dealing with right now is it a hazardous waste? Is it a universal, like a lot of the universal waste guidelines stem from the old lead acid batteries where they did it out of, but a lithium ion battery has a much different hazard profile with the flammability and reactivity than the lead acid batteries do. So getting clarity on that, and then on the end products, if you current federal EPA rules, depending on how you interpret them, classify all the products that are produced from a hazardous waste as hazardous waste themselves. So that creates some import, export, storage kind of question marks. Europe's undergoing a similar thing with the some of their regulations and rules about exporting the products from that are generated from a waste. I mean, we're buying most of these raw materials, so I think that's probably the biggest thing, is just declassifying or finding ways to allow more flexibility for recyclers who aren't as well positioned as ourselves to be able to still do it safely, but not have as much environmental restrictions. Yeah.
All right. Anybody else? Well, really appreciate your time. That's very intriguing information. You got a great company there. Yeah.
Happy to be here.
Yeah.
Always feel free to get my information. If you have any other questions, happy to chat or have an email conversation.
All right. Well, thank you.
Thanks.
All right. Our next presenter is Daniel Rowe with Recycle Force. Recycle Force is an employment social enterprise providing returning citizens with job training through electronics recycling. Mr. Rowe.
Hello. I am not a technical guy, so don't worry about that. I'm a recycler, so I'm gonna get into that. Few comments here before we start. Thank you for having me here today. I want to really focus in on the fact, Governor Braun's executive order, how crucial it is in critical materials and what we're seeing in the e-waste world. In 2023, Recycle Force was invited to partner with the Ames National Laboratory on a grant focused on recovering rare earth materials from shredded electronic waste, specifically hard disk drives. The project was awarded in 2024, and installation of the system was carried out in 2025. Since that time, we have recovered over 100 kilograms of rare earth oxide from hard disk drives here in Indianapolis. This pilot project, and that's what it is a pilot project, was designed to demonstrate a modular process that could be utilized across the United States, where this could be set up at e-waste recyclers all over the United States. So I've just got a few slides, and I'll really talk about the project and what we're doing. As I said, it's a Department of Energy pilot program through the Critical Materials Institute at Ames National Laboratory. Funding for this pilot was to show a modular machine. Now, one hard drive that weighs about a pound, about approximately 1% of that has rare earth containing material. So it doesn't make sense to ship 40,000 pounds of hard drives across the nation when if you can take that and get it down to 400 pounds and ship the concentrated oxide. So that was the impetus for doing this, was to come up with a modular process where that oxide could be got at different sites across the nation and then shipped to a central place in Iowa or wherever they decide to set up. You can see here, this is from our kickoff with the scientific team from Ames. I am not from that side of the coin. I tell you how to break stuff, not what it's made of. Dr. Ikena and Dr. Dennis designed this process in 2016. They actually just won a science award competing against agencies like NASA and the National Science Foundation for the groundbreaking nature of this technology. It's called the ADR technology. It's the acid-free dissolution process that they're using. And I apologize for the slides. I flew back from Ames last night and put this together this morning. Operating the machine. This is a very simple operation. At Recycle Force, we serve formerly incarcerated men and women. And what we wanted to do with this project was make sure somebody with very little technical training could be able to operate this machine. Within 1 week, 2 of our staff from our floor, with no outside of high school, any technical experience, were trained to operate the machine and were recovering rare earth oxide from it with very little oversight from senior staff. Growing pains, this nascent technology is not without its hiccups and bumps. This is a modular system that in scale in Iowa takes up, the entire half of our entire warehouse. So there was some growing pains, pipes that weren't really fit to transport and that cracked along the way, things like that. So as we began this project, we began to learn that this was research. How can this be developed across the nation? Our first shipment of oxide was in August of 2025. After just 3 months, we had recovered 51 kilograms of rare earth oxide. Now, to understand, we're running a batch of about 60 kilograms per time of shredded hard disk drives. Those shredded hard disk drives are the magnetic material. We actually separated the aluminum from the ferrous material. What the important thing is with what we're doing here is nothing is lost. The aluminum is still recovered, the steel is still recovered, and all we're pulling out is the rare earth oxide out of it. So we're not, it's agnostic to the feedstock, and we're not losing any material in it. And it's acid-free, so what we're doing is not using harmful chemicals, and it's something that could be set up anywhere. Feedstocks. So this project started with shredded hard disk drives. They come from predominantly desktop and laptop computers. What you will see over the next 5 to 10 years, that feedstock will be concentrated in a few data centers, because if everyone here has a laptop, you don't have a spindle hard drive anymore. We all have solid state drives. It's all chips. So shredded hard disk drives will become concentrated at data centers. Google, Microsoft, Amazon, all of those companies are looking at this technology as a way to keep a circularity in their hard drives. Following on from that, e-bikes, EV motors, wind turbine motors. These are motors that are used for high temperature applications. Due to the spinning of the motor, they have an incredible amount of magnets in them. Wind turbine motors being the most. Sadly, they're the hardest to recover from due to the fact that you have to use an incredible amount of heat to get the magnets to separate out from the wind turbine. We are beginning some processes working with the Ames lab on e-bikes and some small EV motors on how to recover the magnets from that, what kind of shredding process could be used to separate, and then use it in the ADR process. Power tools. Power tools have powerful rare earth magnets. A lot of people don't realize that. A lot of our older Black & Decker drills do not. They have a cheaper magnet, a ferrite magnet, but a lot of the newer brushless DeWalt, Milwaukee, tools like that do have dysprosium magnets in them. Now, in the world of magnets, dysprosium is incredibly hard to get right now because of the current situation with China. And so having a source for that, especially in EV motors, wind turbine motors, and power tools, is something very important. Now, we've done some preliminary ideas and thoughts on shredding the power tools. It's not very easy. The magnets don't separate out from the motor in a very uniform way. So it's a question of whether it's heat, which uses a lot of energy and has a lot of fumes that go with it, which opens up another area in environmental side, or is there a mechanical way to pull them out? And that's some of the things we're working on right now. So that's really it. This is our team that we worked on this project for. It was generated out of a Midwest circularity. We wanted to be able to have processes that worked across the Midwest where these could be recovered. We work with Current Chemicals up in Northeast Ohio. They do the process to take the oxide to an actual fluoride, and then there's the fluoride that goes to the actual metal. And I think a lot of things, and I think the gentleman from CERBA really hit on it, the infrastructure in the United States is not built out for this yet. We don't have refining capacity. I think next year one of the new magnet manufacturers is supposed to come online. But a lot of this, when we say we're building the plane as we fly, a lot of this technology is being built as we start, as we go along. So thank you. Any questions I can answer?
Any questions from anybody?
Yeah, I just have one. So I know this is a pilot project. Sounds like it's running off of a grant. But
Yes.
What is the economics looking like?
So I spent 2 days working on that just this week with our team. The economics work without Chinese manipulation of the rare earth market. What we have begun to look at is seeing what if the market crashes. Obviously, that's what has happened a lot of times. The Chinese dump rare earths on the market, it brings the price down. Projects like this are not sustainable. At the current levels of the market, it is sustainable. But it's also understanding the geopolitical things. I think, and I'm not going to get into this, but if we truly want domestic production, we have to realize there's going to be a cost associated with that. It's not going to be as cheap as buying the oxide and the magnets from China. And we're going to have to pay a premium for that. So with that in case, yes, it is financially sustainable at this point.
How many facilities do you have where you're doing this?
We're just one. We're a sole facility here in Indianapolis. The ADR technology, which was created by the scientists at Ames, they have a large-scale project that they're doing in Boone, Iowa, just on the outskirts, where they're running. We currently run 50 to 60 kilograms per batch. They're scaled up to run about 600 kilograms per batch. So right now there's only 2 operating facilities for this. And we are just a sole local Indianapolis e-waste recycler.
Are there other entities like Recycle Force around the country or around the state, or are you kind of?
I mean, I think in the e-waste realm, there's lots of e-waste recyclers, obviously. But there's so many different organizations that are pursuing different technologies. This is just one of the technologies, the ADR process. There's all sorts of different recovery methods people are utilizing. This was one that came to us in one of my slides. I didn't really go into it. We have a Purdue connection. This project came because the lady in the front row on the right, she was a graduate student at Purdue, came and toured our facility in 2016, and in 2023 said, she's now a professor at the University of Arizona, said, hey, I want to reach out to Recycle Force. They could be part of this project. I think there's a lot of people that are looking at this type of project, different variances of it.
I have one final, am I thinking about it right, though? You're more mission-driven in terms of jobs for
formerly
hard to
incarcerated
employ,
people, yes.
Less business model, it's more.
Correct. But we look at everything in a sustainable fashion. So in the fact that a project like this, if it doesn't have an ROI after the pilot, we're not going to do it.
Okay, thank you.
How long is the pilot for?
Pilot will conclude later this year, probably September to October. And at that point, we're working with the lab to scale up our equipment to where we could be able to process maybe 100, 150 kilograms a day.
Okay. And who is purchasing this from you?
So currently in this project right now, everything's circular to show it. So it's going back to the lab to be refined, and then we haven't sent it out into the market yet. Okay. In a perfect world, this would go to likely hard drive manufacturers. Okay. You know, Western Digital, Seagate, somebody like that.
What is your pilot's definition of success to move to the next level after the end of this year?
Pilot definition of success will be, first of all, does the equipment work? What we found early on is that some of the rare earth oxide was very dirty and it required multiple washes. Can we tweak that to where we can consistently run and have a clean product that can be sold? So that's number one. And number two is the financial model. Can one person operate this? Is there ways we can tweak different things to make it more efficient and, you know, be able to have an ROI on it?
And you talked a lot about your forward pricing and your model and Chinese dumping.
Yes.
I totally understand there's only two real metal exchanges in the world, in London and in Shanghai, both owned by China. But aren't you using some kind of third-party model outside, like the fast markets or somebody to give you a more smooth look at pricing?
Interestingly, I know that there's a new company on the realm, and I can't remember the name of it, but they're actually using 3 pricing models right now. They're using a Chinese price, a European price, and a U.S. price for rare earth currently, because there's so many fluctuations across the world right now in how this stuff is marketed. So when we were working through this the last couple of days, we are trying to place our pricing at the median somehow in between what the Chinese and what the U.S. pricing is, so that we know this U.S. pricing, which is historically high, is not going to hold. So we have to make sure it works at a lower pricing model. So yes, we are looking at that.
Okay.
So obviously prices for each element are different.
Yes.
And so could you remind us what specific rare earth elements you are getting from those hard drives?
So specifically on this.
Could you repeat what her question was into the microphone so people online can hear it? Thank you.
Maria asked about what specific rare earth elements we're focusing on. Hard drives are specifically neodymium and with a little bit of dysprosium in it. So that's primarily what we're focusing on, is the neodymium pricing on that, because we're creating an ND mix in what we're coming from in the oxide. But that's the pricing that we're using. Dysprosium, there's such a trace amount of it, you couldn't really price against that.
Any other questions? Comments? No? Well, thank you very much for your time.
Thank you so much.
Yep, very, very interesting. All right, our next presenter is Sam Rosalina, Microbial Insights Incorporated. This is a biotechnology laboratory offering microbial diagnostic solutions through innovative molecular biological tools, MBTs, including qPCR, next generation sequencing, stable isotope probing, and patented passive microbial and mineral samplers. I can barely say
It's
it
a
all,
mouthful, it's
so
fine.
that tells me that you're going to be a lot better at this than me.
No, well, no promises. Thanks for having me, folks. I'm Sam Rosalina. My background is in analytical chemistry. I'm slowly becoming a microbiologist over the past 10 years of working with Microbial Insights. I'm the vice president of this lab, and just to be clear, we don't sell any kind of products. All we do is microbial testing. So we act often as a third party to ensure that the microbial work that is happening in the world, whether it's environmental remediation, whether it's rare earth element extraction, is accurate. So we act as that unbiased third party. So when it comes to the mining industry, when we're talking about the role of microbes, we're seeing more and more interest in this process and what could occur within the microbiology realm. Kind of similar to human health, wherein not too long ago we recognized the importance of the gut microbiome and how much that impacts us as humans. We're starting to recognize that plays a role in lots of different industries, including the mining and reclamation industries. So there are multiple ways to mobilize metals. There is, in terms of the pros and cons of the mobilization of metals, there is the good side, which is being able to recover these rare earth elements and critical materials. There's also bioleaching and biomining through that mobilization. The cons are that there is also the acid rock drainage or acid mine drainage that occurs through this mobilization of metals. There's also immobilizing metals, so trapping those metals. That can be heavy metal precipitation and remediation. That can also be extraction of those rare earth elements. But the cons can be that there could be biofilm formation and scale formation, which could cause issues with the processes. So monitoring the microbes is crucial to all of these potential processes. Now we know that there's an increasing demand in rare earth elements, and there's an increasing cost requirement for some of this, especially when we're talking about some of the work that's being done in recycling different ores. And so we're constantly looking for better ways and more cost-effective ways to do this work. And one of those is through microbial mediation of rare earth element extraction. So, as the executive order says, there is an interest in extracting these critical materials and rare earth elements from coal byproducts, from spent coal byproducts. And that's crucial, of course, in Indiana. Indiana holds over 100 different coal ash pond sites. And so turning that coal ash into valuable minerals is really crucial. And so it's been noted, as is said in this paper and as has been written by Oak Ridge National Lab, that notably coal ash has the potential to yield approximately 312,000 tons of REEs annually, which by far exceeds the global demand. So the question then is, how do we do that? When we're talking about microbial processes that can help with recovery of critical materials, there are three kind of key areas. One is bioabsorption. This is where metals are kind of bound to those microbes themselves, or in some situations, those microbes bring those metals inside and use those metals within proteins. There's bioaccumulation, wherein microbes produce compounds that grab and hold on to those metals. And then there's bioleaching, where these microbes produce things like acids that drive those metals out of ore or out of coal ash. So there is research, quite a bit of research on the biotechnology side of mining. This is not necessarily a brand new idea, using microbes to help us extract these elements, but it is somewhat in its infancy. And so that's where Microbial Insights comes into play, is we work closely with a lot of different industries. We work closely with a lot of different universities to take research and turn it into actionable and application-based work. So some examples of this are things like heavy metal processing within coal ash waste or within spent mining tailings. And so one example of this is metal reduction that was being seen in a lined surge pond. So what they were seeing was a lot of high heavy metal concentrations going into this surge pond. But on the outlet of this surge pond, which flowed into a smaller pond, they were seeing great reductions of the heavy metals that were there. And so the questions were, because they weren't adding any processes themselves, there were no mechanical processes involved, they wanted to know, were there microbes that were responsible for precipitating out these heavy metals? And as we know, if we're treating coal ash, heavy metals is a big part of that process. We have to understand ways that we can deal with these heavy metals in conjunction with extracting these elements of interest. And so again, we see precipitation, bioaccumulation, and bioabsorption playing a role. So real quick, and not to get too technical, but what we do at Microbial Insights, instead of the old school ways of taking a sample and trying to grow it on a gel plate and looking through a microscope and trying to count those microbes, what we do now as an industry is actually do DNA analysis. This is not dissimilar to 23andMe or any of these analyses where people look at their own genealogy. What we're looking at are small sections of DNA that tell us anything we need to know about these individual microbes. And so we can look for very specific organisms, and we can look for very specific tools that they might have in their toolbox. So essentially two categories. Who are they? What are their name tags? And what tools do they have in their toolbox? Can they grab those heavy metals for us? We can also, through some work that we do, we can do lots of these targets simultaneously from the same sample. And so we call this an array, and we have a specific array dedicated to biogeochemical processes. So in this case study, what we did was take that array and we applied it to look for key targets related to heavy metal precipitation. All of these kind of gold boxes are targets that are included in our array. The blue boxes are typical kind of chemical analyses or metallurgical analyses that are used to confirm some of this work. But if you imagine this whole group without those gold boxes, there's a lot of information that's missing, which again is the crucial part of doing this microbial analysis to fill in those gaps. So looking for nitrogen cyclers, we know for a fact that these organisms precipitate and absorb heavy metals. If we look at the blue bars versus the orange bars, the blue bars are the inlet of this surge pond, and the orange bars are the outlet. What we notice, of course, is that there is a much higher abundance of these organisms that do nitrogen cycling at the outlet. So we know for a fact that there is likely a lot of precipitation and bioabsorption of these heavy metals occurring. We also know through publications that nitrogen cyclers also precipitate carbonate. This is interestingly used to heal concrete cracks. This is some research going on using these microbes to kind of passively heal concrete cracks, which is fascinating. But we also know that through this process, through the formation of carbonates, that we can also additionally precipitate lots of heavy metals like copper and lead and cadmium. We also know for a fact that these same organisms can bind these heavy metals directly to their lipids, essentially kind of like their skin cells. So there's a lot of processes where those nitrogen cyclers play a role. There's also a group of metal cyclers that we know for a fact precipitate heavy metals. Again, we see a much higher abundance at the outlet of this surge pond compared to the inlet. We know that sulfate reducers and fermenters can dissolve, that sulfate reducers, first of all, precipitate these heavy metals, and that fermenters are not necessarily a good thing. They actually mobilize those heavy metals. What we notice is that the fermenters stayed pretty consistent, so less mobilization, but those sulfate reducers that precipitate heavy metals much higher at the outlet. So we were able to, with this process, show that microbes are actively playing a role in heavy metal precipitation and remediation of surge ponds, which helps when you think about modular processes that this can feed into downstream to better precipitate the elements of interest in a much cleaner way, so less contamination from other elements of concern. We also do a lot of corrosion assessment because microbes, as it turns out, play a huge role in corrosion. This is an issue all over the world where we see assets that are impacted by microbes that produce acids, or they infiltrate small cracks, or they essentially cause ionic changes that make the pipelines or assets batteries, so you get pitting that occurs. And so we do a lot of analysis on all types of different pipelines. We work across the globe with petroleum companies as well as water and municipal outlets. And so this was a uranium mine where they were looking at issues. They saw lots of corrosion on these what are called metal coupons over time. And so we were able to, with our analysis, show that there were high abundances of microbes involved in those corrosions. And of course, this plays a huge role when it comes to the future of what this executive order is talking about, which is there's going to be a lot of mechanical processes that have to be involved, which often means a lot of corrosion as well. So microbes playing a big role in every aspect of this process. Now, the most important thing and the main thing I'm here to talk about is bioleaching. So how can we take that coal ash and how can we remove the elements of interest from that coal ash in a passive way? And when I say passive, it means less hands-on, which means more cost-effective. It means more sustainable overall. So some examples of this, there's a big push for using bioleaching for copper extraction. Around the globe, as much as 70% of copper is tied up in really low-grade ore. So a lot of this ore are spent waste. You get rock piles from mines that recognize that there was quite a bit of of copper in these rocks, but there was also a lot of sulfur and sulfides, which would make it too costly to pull that copper out. And so there's these piles of rocks at these mines that are just filled with this high copper, but also high sulfur ore. And so the questions have been, what can we do to get that copper out? Again, as I said, coal ash is very similar, where we see the potential to yield 312,000 tons annually of rare earth elements. The annual global demand in context is 200,000 tons, so far greater annually that we could get from coal ash. So these ore and this coal ash, they sit there because there's not cost-effective methods to pull those out yet. Now, the microbes that come into play, and forgive the cheesiness of these little organisms, but these microbes are impressive because, one, they can access very small spaces, so they can get to that copper directly through fissures and pores within the ore itself. You can't do that very easily. This is why it's so costly to get to the copper in the first place using mechanical methods, because you're crushing a lot of these rocks. These organisms also have the capability of weathering those rocks directly, so they can actually break down the rocks as they leach these metals out. Now, there's a lot of organisms that can do this naturally, because there are a lot of organisms that utilize and require copper to survive. But there's a lot of companies that are looking directly into genetic modification, so using either forced kind of evolution in the lab or actually doing genetic modification directly to the DNA to kind of hyperactivate these organisms to make them even more effective. What that means is that they hold those consortium, that group of bacteria, in a pond or in a tank nearby, and they will spray that consortium over time on top of these ore. And I'll show you an image of that here in a second. And so what we're seeing is that we're getting quite a bit of good bioleaching that is much more cost effective than trying to crush this ore over time and break it down and then send it through very aggressive chemical processes that result in a lot of additional hazardous waste production. Now, when we're talking about bioleaching from coal ash, there's been quite a bit of work done in academia. This is this chart on the right shows leaching efficiency of all of these rare earth elements. And so you're seeing around 70% leaching efficiency for some of these, like ytterbium and scandium, really crucial elements here that are being produced just through the leaching of coal ash by certain organisms. So we know a lot of these organisms exist, and we know that they can do the work. The question next is how they're applied and monitoring them over time, both in terms of showing that they are present and doing the work, but also ensuring that they have everything in their environment to be happy and healthy in doing that work as well. So when I talk about the heap bioleaching, and this mostly applies to that copper ore, this is what it looks like. So spraying this consortium of bacteria on top of this leach consistently over time. Those microbes then get into the cracks, they produce acids, those acids kind of extract that copper runs downhill, you see how it's placed on an angle, and then it's caught in a pool at the bottom, wherein additional processes that are needed to purify that copper go into place. And there are a number of different companies that are actively working on this. Some of those companies are huge, like Battelle. Some of them are smaller, but are showing true promise, like Indolith and Alonia. And all of these companies are working with a very similar process in mind, which is using these microbes, but they have different end goals. Indolith is using microbes directly, so applying those microbes directly. Battelle has published papers on the use of proteins that have been extracted from these microbes, and those proteins further purify these rare earth elements. So what that means is you can get extraction of these rare earth elements directly from these microbes that are living on the ore, but then you can also use the proteins that companies like Battelle have purified to further separate those rare earth elements, which is the more difficult thing to do, purifying and separating those rare earth elements. So all of this being done through biological processes. So then the question is, how viable is this? I can tell you that Indolith has done some real-world case studies. Battelle's process has only been shown to work up to 50 liters, and they haven't been able to show much higher than that yet. But Rio Tinto, which is a global leader in mining, has a new process called Newton, which uses a lot of these microbiological processes in conjunction with artificial intelligence. And what they've shown recently was a huge breakthrough on a full-scale pilot study where they recovered 85% of copper from really low-grade ore. This is unheard of. And it required 80% less water, 60% lower carbon emissions. So the answer is that this is actively happening. We know that this can work and can be applied to copper ore. That's a great question. I think it took them about a year that they did that pilot study. Now, they've been working on this project for 10 years. So Rio Tinto has been involved kind of early on in the game, which is why they're ahead of that curve, I think, and compared to a lot of these other organizations. So to kind of summarize everything, we know that there are a lot of microcosm studies that have occurred in academia that show that this is an effective and cost-effective way to extract rare earth elements. The question next is, can it be applied? And that's where organizations like Microbial Insights come into play, which is bridging that gap between research and application. So we want to help in whatever way that we can with the state of Indiana and pitch in with any of our connections that we've made through these companies that are doing this work or with academia that we work closely with as well. And of course, throughout that entire process, we are involved in helping prove that those studies are occurring, helping prove that full-scale pilots are occurring actively, showing that we can treat biofouling issues where we might have slime formation from these microbes, helping with corrosion and asset risk, and then of course bioleaching of the metals themselves, as well as precipitation of the heavy metals. So I know that was a lot and potentially pretty technical, but I would love to take any questions that you might have.
Is there federal funding backing up any of this research?
There is, but I don't know that it is, I don't know to what degree. I know that there has been, but I also know that that federal funding has decreased over the past couple of years. In terms of the bioremediation.
Would you consider this a national security, in a category around national security?
I mean, I think anything related to rare earth element extraction is national security. And so if we can harness the nature-based solutions that have already been given to us by nature, and that slingshots us forward, then why not take advantage of that?
Just make sure I understand, this is a little new here.
No
so
worries.
You're spraying.
Well, we are not, so we just do analysis, but these companies, yes.
They would be spraying. Now, is there environmental concerns here? Any special tests that need to be done for permitting or anything else to put this into play?
In the U.S., there shouldn't be. And these organisms, like I said, are typically indigenous organisms. They're organisms that already exist in the U.S. So it's not a Jurassic Park situation. They're not releasing a bunch of organisms that are not known. When we talk about genetic modification, groups like Indolith are using that term pretty loosely because they're not making a whole new organism. What they're doing is they're taking organisms and then they're slowly feeding them copper ore, and then they separate the ones that are doing better than others. And so essentially what they're doing is taking those same groups of bacteria and kind of fine-tuning the ones that are doing the best work. Just like you would with an apple orchard, right? The ones that are producing the best are the ones that you plant the seeds for.
In the absence of government funding, is this an area where there's a lot of investment?
Yes, and that's what we're seeing with a lot of these companies, right? These are companies that So Battelle, I don't know if you're familiar with Battelle. Battelle is a nonprofit. Their whole goal is to invent and then lease or sell patents. So they invented the barcode. They invented compact discs. They invented cruise control. So they're putting a lot of money and effort into this kind of work. And I think if you're looking at organizations like that and seeing where their focus is, it's usually a good sign.
So following on with that, like if you project 5 to 10 years out, does this become a commonplace
Absolutely.
treatment?
Yeah, and I think
Is that fast enough, 5 to 10?
100%. Yeah, and I think with companies that have a lot of capital behind them, companies like Rio Tinto, who are already showing this at full scale, then I would say Rio Tinto is almost certainly going to apply this to their copper mines globally. And so my guess would be that that's going to be occurring over the next 3 years. And that's copper specific, to be fair. Indolith is focused heavily on lithium additionally, but I think these rare earth elements, now that we're seeing lots of focus all at once, a lot thanks to this current administration on rare earth elements, then we're getting funding from lots of different directions that could act as different modules to make this happen faster. So I also want to be clear that there's no silver bullet, right? So these organisms are doing a lot of the heavy lifting for us on the front end. And so there will be a lot of work done on the back end to purify those metals in those elements and incorporate them in different ways. But if we can cut out a lot of the work on the front end by using microbes rather than big, heavy equipment, then it's going to be extremely cost saving.
All right, so we're spraying, we got microbes collecting. How are we then, can you help me with the rest of the process? Like I guess I'm having a little bit of trouble understanding how we're actually collecting.
Yeah, so essentially what you're getting collected in this pool, let me turn on my laser pointer here. If it can be seen. So here in this pool is where the liquid is collected. And this is exactly the same as current chemical processes. So right now, instead of using microbes, ore is typically sprayed with very aggressive chemicals that wash that copper out, right? And those aggressive chemicals don't get into the cracks and fissures that these microbes can, so they're not as effective. But you're getting the exact same thing. So if you replace the sprayers of microbes with sprayers of very aggressive, hazardous chemicals, you're not changing the process really at that point. It's just that these microbes are producing the acids themselves, and so you're getting a lot less waste and you're getting direct contact with those elements. So from there, downstream, it should be about the same.
Right, so we're eliminating acid leaching basically, but we're still going to get to this point where the refining, maybe not copper or whatever, but for rare earths is still going to China, I'm assuming.
So not necessarily. So this is where Battelle's technology comes in. So Battelle took information that they had on what microbes were around. There are certain microbes that produce proteins that separate these heavy metals or these rare earth elements out. And that's the hardest part, is the separation of the rare earth elements. What Battelle has shown is that even at very low pH levels, that they get great separation of heavy and low rare earth elements. And that is the trickiest part. That is the most cost impactful part, is that separation. So what they do is they use these microbes, they get these microbes to produce a lot of these proteins. They then purify those proteins and stick them on kind of like, you can imagine ribbons in a big column. So you have a lot of these proteins on these ribbons. You then pour this extract through that system. This is very overly simplified, but essentially it's the process. It goes through that system, through that column, and those proteins separate and bind those rare earth elements. And so you get those proteins grabbing onto those rare earth elements, and then you can wash that column with different things to remove the rare earth elements that you want. So you get purification through that process. And so they've shown, again, I think the last time I talked to them, they had only done 50 liters of this, which is not nearly enough, but it's not because they can't do more, they just haven't tested more. And so they're in a process where they're taking this, again, they make patents and sell or lease them. They're not trying to turn this into a big product. So they're kind of shopping it out to companies that can be promising and making that happen. So all of it is here, and it's also has been here for a long time because it's all microbial based.
So one last question on that front. What would the cost, I mean, I know this, but what would the cost comparison be between spraying microbes and spraying the sulfuric acid or whatever else?
I don't know exact cost, but again, we can talk about recovery rates from, and I also want to point out that this is being done in ore that was already deemed to not be worth spraying sulfuric acid onto, right? So really low grade ore. So you're talking about, in some ways, it's hard to compare because it wouldn't be extracted otherwise unless you were spending a ton of time crushing all of this ore and using sulfuric acid. But when you take into account how much less energy it took, when you take into account how much less water it took, and as I mentioned, it's going to take a lot less chemicals in general because those microbes are producing the chemicals themselves and more kind of effectively, you can be guaranteed that there will be cost reduction.
Are there any other questions?
Maria, yeah.
So I'm thinking about bioleaching of coal ash, what you said.
Mm-hmm.
And I wouldn't expect that the rate of bioleaching would be really high.
Mm-hmm.
So as a result, I'm really kind of thinking that, and I do know those studies that you showed how, what the experiments were done on leaching, and it's possible, but we have to remember that in coal ash, this is this glass material that went through such a high temperature, and it's so hard to chew into. And as far as I know, microbes, they need to have something into chew, So I would expect that it would be much higher rate of success if we deal with coal tailings or coal slurry, for example, what we have in Indiana, that we still have lots of organics there.
Yes, yeah.
That we have much lower, kind of not so temperature changed environment.
Mm-hmm.
And that's where I see much more potential for this. For coal ash, it's possible, but I'm thinking that the rate of bioleaching and the result that we get, it's much more doubtful that if we could try that on coal tailings or coal slurry.
Mm-hmm.
And I don't know how much research has been done, not much as far as I know, on those type of materials, and these are those that we do have quite a bit in Indiana as well. And we have to remember, microbes it's a huge group. It's not just very specific thing. We can have bacteria, we can have methanogens,
Right.
all kind of things. So I don't think we are at the stage yet that we really understand which groups or which individual species will work best. But definitely it's something to lot to study. But it has potential, but also we cannot expect so much so fast.
Yes, I think there's a lot of truth in there. I want to point out a couple of things.
Could
I'll
you
repeat
kind of
it back in.
synthesize that for
Absolutely.
everybody? Yeah, thank
so
you.
Maria asked a couple things. One is, do we think that this could actually happen at any kind of helpful scale in some of these slurries that, especially ash, where there's less organics for those microbes to eat and be sustained on, rather than slurries or tailings? And then the other question or point was that there are a lot of different microbial organisms, and maybe we don't know exactly which ones are playing some of these roles. Is that fair? So a couple of things there, these are great points. One is, as an analog for this, we do a lot of work in the environmental remediation industry. There are a lot of organisms that degrade petroleum hydrocarbons, for example. If you spill at most gas stations nearby, there has been a leak from an underground storage tank at some point. We work a lot in those situations because if there's a spill of these compounds, there are organisms that show up or are usually already present that can degrade them. There are also situations where there are organisms that are trying to degrade other things, and what happens in the industry is we provide them with that carbon. So they have the food source that they need in order to do the activity necessary. So in some situations, it may be required to what is called biostimulate these organisms to give them something very easy to chew on while they do some of these other processes that are really important. But that's a really good point, which is one of the reasons that we do a lot of the analysis that we do across all of these industries is to make sure that these microbes have what they need in order to do the work that they are doing. The other case that I want to point out is that we do know within these studies, we don't know all of the organisms, but we certainly know very specific ones that are doing some of this work, which is helpful. And then there are also additional studies beyond this that take into account other technologies. So for example, with some of these harder to access elements within coal ash, there was a great study recently of hydrothermal alkaline process in front of these microbial bioleaching where they saw really good recovery. And so I do think it's going to take more than just, like I said, I would never say that this would fall solely on the shoulders of these microbes, but I think that they can greatly cut out a lot of the work that it takes. So you're right, though. The question now is, how do we show that this is happening at scale? And I think this is where funding needs are needed to really push that into the forefront and increase the rate that this kind of research is happening, because it is happening. And we know that it can be effective and cost-effective and sustainable at these scales. So we would like to kind of make sure that that's happening and capable at these larger scales as well. Any other questions?
Well, thank you very much.
Thank you all.
Yeah, that was
Really appreciate it.
very interesting. Okay, our next presenter is Vince Phipps. He's the CEO of IncLogic, and they are pioneering autonomous aerial dominance. He's got his team with him, so I'll allow him to introduce them when he feels necessary. And I am going to have to pop out, but Senator Greg Good has agreed to go ahead and lead the meeting and wrap it up and everything. And trust me, you're in much better hands.
I appreciate it. Thank you, Alan.
Yeah. And Greg, just for the record, the Pirates are up on the cards 2-1 right now. So, update. Thank you all.
Thank you. Well, first, thank you for allowing us to be here and be part of the conversation. The good thing is all that technical stuff, now we don't have to do all that because you kind of understand that, right? And we can just kind of talk about what we're trying to do. So just to give you a little background with IncLogic, we actually started out as more of a drone for the military. I'm a veteran myself, so is Ralph Stewart here. We served together in Desert Storm. And most of our leadership is former military. So when I originally designed the drones, they were actually designed for military. I got a chance to speak with Josh Steele and some of the folks from Crane, and they said, hey, you know, your hazmat version that we were designing for the military could work for this remediation process. And so we've adjusted some of the technology that we have with the drones that'll actually help with the remediation. So as we all know, as we've been hearing today, we know what the problem is. You know, Indiana has, over 100 coal ash sites across the state. You know, there's, you know, for a lot of it, there are a lot of great resources, as everybody's been talking about today, that we can extract from that. The problem is how do you do it, right? It's really unsafe. When you talk about, you know, using humans to go into there, those areas are extremely toxic. And so what we have to be able to do is look at those ash piles and say, okay, how do we best remediate that and then turn those into rare minerals? So, you know, this is kind of what we're looking at right now. We all know it. You know, the ash ponds, the mines, and the coal ash. The idea behind that is, as InkLogic, is we call our solution Mines to Motors. This is really going into those areas, remediating those rare minerals, and then using that to create our drone sovereign program. So we all know there's a shortage in magnets, lithium batteries, you name it, there's a supply chain shortage, or we're heavily dependent on China. What we're able to do by setting up our platform is extract it, refine it, fabricate it, and then build our drone systems based off the parts that we're going to solicit from these remediation processes across Indiana. So we have really 3 divisions. We have our Ink Mining and Minerals division, which is really going to be the spearhead for extracting those minerals across Indiana. The second company is called Spydertech, and that's really our drone making company. And on top of that, not only will we process our own drones, but we'll also make all of our drone products in-house. So you're talking harnesses, you're talking all the fabrication, you're talking all the optics, everything will be made in-house at our factories. And then InkLogic is really the parent company that kind of oversees it all. Part of what we're doing is we have already entered into a master research agreement with Purdue University. We just identified 53 acres right near the Purdue Airport, so we'll be able to utilize the air corridor and Purdue's airspace to do our testing. They're actually, Dr. Larry Foltz was supposed to be here today, but they're actually pouring the mold on our first prototype today, and he wanted to stay back and make sure that went according to plan. So our first prototypes will be ready by mid next month. We'll begin the testing. The testing is probably going to take about 60 to 90 days to do all the testing that we need to do. And the difference in what we're doing with our drones, and we'll talk a little bit more about that here in just a bit, is our drones are tri-domain drones, which means they can not only fly, but they also have train traversing capability, and we also have a technology that we call surface scaling capability, where they're literally can able to walk up walls and perch themselves on ceilings. So we'll get more into that in a little bit. For our leadership, Army veteran, my COO for InkLogic is a Navy veteran. He was actually a Master Chief for the drone program with the Navy, so he has the experience and technology behind that. We have our Chief Financial Advisor, Ronnie Morrison, who is executive with both USAA and with Chase Bank. Jessica, who is here today, she's our Chief Human Resources Officer, and she's going to talk a little bit about our factories and our employment program. We have Kurt Carell, who's our COO of Ink Mines and Minerals, and he'll talk a little bit about that process. Our division president for our Spydertech, he can't be here today, but he's also retired Army. And then Stuart, our president with InkLogic, is here with me as well. So that's our team. I'm going to hand it off to Jessica, and she's going to talk a little bit about our process.
Yeah, thanks, Vince. All right, so with that leadership introduction, I'll segue to our economic engine, and I want to look at that through the people lens and the direct impact that this will have on jobs. So when we look at our launch flagship site location, our launch site location in West Lafayette, at full capacity, we're looking at 1,160 positions that will be at that location. And as we prepare for broader business expansions to include a North Campus and a South Campus, those locations combined will add roughly an additional 2,000 jobs. So in total, looking at almost 3,200 newly created opportunities across the state of Indiana, which is incredible. And so when we prepare for that and looking at our human capital management strategy or our talent strategy, there are a couple of pillars that I like to look at when working through those. One of those pillars is the attraction of candidates, and the other pillar is the retention of our employees. So there are some key indicators that we'll use when working through that strategy, and one of those key indicators is pay. So as we forecast our growth and build our compensation structure, it's crucial for us to stay competitive as we look at these pay grades and the positions that we'll have in our business and be above market data. So you'll see some again, positions that are integral parts of our daily operation, everything from entry-level intern apprentice type roles all the way up to our senior operator positions and a lot of other technician roles in between. And again, our goal here is to not only provide positive financial well-being for our employees, but also to support that talent strategy as we attract and then retain those people. Yes.
How many people do you employ today?
So we are still in startup phase today. So we haven't yet hired any of these technical or operational roles that we'll have. Yes, still working through our leadership capacity. Great question.
So the expansion, you're looking at sites now?
So,
Or-
and Vince, do you want to talk about
Sorry to interrupt.
No
you're
problem.
good.
We appreciate the questions.
You're good. Yeah, like I said, we just signed our master research agreement. We are securing 53 acres with Purdue. Actually just met with Mike Rourke and his team. So we are hoping to break ground by September is the plan.
On the flagship.
Yeah, on the flagship, the West Lafayette campus. The idea from talking to the builders, we're looking at, he said 10 to 14 months to have 3 of the 4 buildings online, and then another 6 months to have the final building online. Yep.
Thanks, Vince. Any other questions? Wonderful. Okay. So the other key indicator that I want to call out, and related again to that talent strategy as we think about all of these newly created positions, is benefits. And a lot of times employees are a little bit nervous, right, when it comes to the benefits perspective, because it can be costly. And so our dedication to our employees is to offer a 100% employer-paid benefits package for our employees and their dependents and their families to support that, again, just overall employee well-being, and to take that burden off from a premium standpoint, which can be, again, costly. With that, we'll also have a 401k plan that is available for our hourly and salaried employees to participate in, that offers immediate vesting from day one with a 100% employer match up to 6% of the employee contribution. In addition to that, a fully paid family leave program for different things like maternity, paternity, adoption, other family leave planning appointments, and that'll be in addition to any federal or ancillary benefits that the employee has available to them. We'll also have a military family leave policy that is fully paid and available to our military employees, as well as support for their families during coordination for deployment. And as we talk about our military workforce, I also want to call out, and it was mentioned, right, that we're a veteran-owned business. We also have built within our hiring framework to have a targeted veteran workforce of at least 25% of our employees. And as we do that, we'll offer priority hiring for our service-connected veterans and their family members. And in addition to our normal employee rewards and recognition program, we will also have highlighted veteran spot awards available to those veteran employees, and different recognition programs that allow us to exclusively honor and recognize veterans that are demonstrating exceptional leadership while working with us. So I'll pause there, and I'm going to pass back over to Vince to talk a little bit more about our architecture.
Thank you. Any questions on the first part before we move on? Okay, thank you. So when you talk about the remediation process, the goal for InkLogic is to handle the bulk of the remediation at the site. And then, so what that will look like is, once our prototypes are done, which again, we expect them to be done here in the next 4 to 6 months, we want to be able to immediately start to send out our prototype drones once we have proven that it works the way that we think in our heads, or at least the schematic looks like, to go out and start mapping these areas out. So that'll give us time while the rest of the facilities are being built. That'll give us the time to go ahead and start to detect and get samples from all of the ash ponds, the gob piles, or the AMLs, so that way we understand exactly what's in those. And so our partnership with Purdue is going to help with that. So we already have a few meetings already on the books. I've already had 2 with both the biochemical engineering folks, the chemistry folks that are actually going to pair with us to make sure that once we get those samples, they're going to help us analyze that. And that'll give us the direction when we deploy the rest of our drones to know exactly what we're going to be extracting from those different areas. So once that happens, the detecting, the mapping is done. Again, the remediation will be done on site. Now, I know a lot of folks talked about pouring sulfur and spraying it. we're going to stick with something that's simple and already proven. We're going to grind it up, we're going to crush it, and then we're going to bring it back to our plant, process it. It's really simple. I don't want to try to complicate it any more than it needs to. There are certain things that we're going to be trying to pull out of it. That's the iron alloys, because that's going to help with the magnets. Whatever lithiums we get out of that, we'll certainly process that and use what we can from that. But this is really to create a sovereign supply chain for our drone dominance program. That's the real goal here. So once it's been ground up, extracted, remediated right there, it'll be loaded into the spill trailers. Before they come out of the toxic area, we already have drones designed. Again, when I talked about the military decontamination, those same drones will decontaminate the drones that come out of the toxic areas. And then before they move to the next area, which will be loaded up on vehicles or trucks, that will then bring it to our facility for the remaining process for those rare minerals and start to turn it into products that we can use in our other factories. Now, I do have, I'm sure you guys are familiar with the Merrill Brothers out of Kokomo, Indiana. I've known those guys for 20 years, so they're going to help with the trucking of bringing the products back to our facility. I also have a call into Tierra Environmental. They have a great, because they're going to be helpful for the gob piles, because a lot of them have been covered up with stuff for a while, and so we're going to have to remove some of those top layers in order to get to those, and so they're going to help us with that, and then we'll get it trucked back to our facility to create the rest of the process. So the goal is to keep everything that we do right here in Indiana, using partners that are right here based out of Indiana to make sure that we're doing everything we possibly can for the state of Indiana. So that's our plan and that's our goal. So once it gets to the decon, it loads up, and then it's just rinse and repeat. They go right back in and start the next round of the remediation process. And if you see that, if you guys can see that picture, but that's kind of gives you an idea what the drones will look like. It's the reason why we're called Spider Tech, because that's what they look like. So again, talking about the remediation process, we have 4 drones. It's basically 4 chassis, and it's just different sizes. The smallest size is probably about the size of this. It's called our NAT, or our micro drones. The next size up is probably about the size of a medium pizza box. The next size up from that is about the size of a riding lawnmower. And then the full size, the Super Goliath, is about the size of a medium SUV. So those are the different chassis, and all of those drones will be a part of the remediation process. So when you talk about the drone competitive landscape, we're the only drone that has that tri-domain. You have drones that are on tracked wheels. They can only access certain areas. They can't go everywhere. So they're limited to what they can do. The flight-only drones, again, are very limited. They can do some aerials, they can do some inspections, but they can't really do the hard work that it's going to take to remediate it. And then the wheeled robots, while they have great mobility, they're still limited to how far they can go into the mines or certain areas. Spider Tech solves all of that, and we're the only system that does that. And when you talk about competitive landscapes, not just with drones, but your traditional contractors, right? Again, the high cost to do your traditional contractors has to go in, dig the stuff up, try to move it. It has a lot of human interaction, which puts them at risk. Again, we're the only company that can do this 100% autonomously, extract those rare minerals, and then turn that into products that can be used on the open market and commercials. All right. Talk a little bit.
You got it. Thanks, Vince. So as Vince has mentioned, and a couple of the other colleagues have already talked about kind of the process around remediation. There's a lot of folks a lot smarter than I am that can probably walk you through even in more detail. But at the end of the day, it's 0 tailings piles, 95% recycling. And this plant will be housed, our #1 plant will be housed, as Vince mentioned, in West Lafayette. The EPA compliance framework, that's all being built as a part of it. So it'll literally be a closed loop process once that material goes from the mine site in each of the districts up to the site at West Lafayette. Can I ask a question, please? Sure. So the process will be at the West Lafayette? That's correct. Start to finish. What about the actual fabrication of the drones?
Also
at West Lafayette.
Yeah.
So
Yeah, let me help you with that. Yeah, let me help you with that. What we're building right now is a 6-building campus in West Lafayette.
Sorry, I didn't mean to interrupt.
No, you're good.
Oh, good. No, 100%.
So the ink mines the mineral is going to be about a 250 square feet building that'll actually process the hydromet that we're talking about right now. Will actually process it. There will be a 50,000 square feet drone manufacturing plant at the West Lafayette campus as well. There will be another QEM facility that actually makes all the products for the drones that will be at that location. We are also adding, it's a nano fabric facility. Again, going back to the military version of this when I created it, is the drones will have their normal chassis, carbon Kevlar chassis that they're going to be made out of. On top of that Kevlar coating, there's going to be a thin layer of solar panels that can extend the life, so if they have to be deployed for a length of time, it'll keep the battery charged. And then on top of that, we're going to manufacture a CT nano fabric that's actually radar reflecting. So that's what the fourth building will be. Will be the facility that'll manufacture the nano fabrics for those kind of things. The other facility will be a semiconductor facility. Because again, that's one of the things that we know is the supply chain shortage. And so the fifth building will actually be a semiconductor, and then the sixth building will actually be a transformer production facility. And all of these rare minerals will go to facilitate and support all of those locations.
So picture back in the day, right, we had steel mills up north, right, creating the steel, and we had auto manufacturing. Same kind of process, just taking rare earth minerals from our ash ponds and glob piles into Vince's vision, making West Lafayette basically the center hub for that. Okay? All right. Rainwater usage is it's a hot topic in the state of Indiana. Everybody talks about data centers, the volume that they have from water. Our process utilizing rainwater will be collected on site. We have a number of different processes and solutions there to make sure that our impact for rainwater and local utility water in Tippecanoe County is kept at a minimum. Okay. And then next up for the four-phase roadmap, Ralph's going to walk you through it. Okay.
Good afternoon. This is our four-phase demonstration roadmap. Kind of breaks down by phase how long it's going to take. So 6 months would be phase one, the rapid guide pile demo with Spidatech, Fleet, and I can't see that very well, Hydromet pilot. Phase two would be the ash pond pilot with scaled processing and environmental monitoring. We expect that to be right around the 12-month mark. Phase three, multi-county AML integration with regional processing hubs. We expect that to be right around the 18-month mark. And the final phase, phase four, would be statewide infrastructure, trained workforce, and supply chain integration, 24+ months. Mind the Motors for Indiana National Leadership Movement. First mover advantage with the national model. Indiana has the resources, the partner, the validation, and the funding to lead this conversion. No other state combines this coal waste volume, research, partnership, autonomous capability, and active recovery council. The alternative, other states capture it first. That leaves Indiana behind the power curve. You get ahead of the ball, you kind of set the rules. Indiana manages the liabilities that cost if you fall behind that. Mines and Motors delivers extraction through materials and production, ready for immediate deployment with the drone process. The ASK, board endorsement to establish Indiana as a sovereign command node for an 18-building statewide remediation and manufacturing ecosystem. Recognition of the 18-building statewide architect, support for the West Lafayette flagship as the sovereign headquarters, authorization to proceed with the state-level coordination that's in alignment with the Executive Order 25-62, and formal backing for federal engagement of DOE, DPA, EPA, and DOD. We're not just asking for funding, we're asking for alignment, endorsement, and the authority to execute.
Any other questions for the team? You didn't talk at all about patent or IP protection. Can you talk a little bit about that?
Yeah, so of course, we're currently into the master research agreement with Purdue. Right now, SpiderTech and InkLogic, we have 40 patents we've already submitted for. That covers our drones. We have additional IPs that cover some of the internal components that will help with not just the remediation process, but that also covers our entire military variant as well. One of the other drones that we are working to come to market with, again, working with Josh Still and Crane, we have a Never Alone package. I'm sort of getting off script, but I just kind of wanted to let you explain kind of what we're doing with our drone program. It's called a Never Alone package, and basically what this drone does, it'll actually nest on top of a cruiser. And let's say they pull somebody over, the drone will actually take off, catch up to the vehicle. It'll do a complete scan of the vehicle, checking for weapons, identifying how many people are in the vehicle. It also has a two-way hands-free communication and facial recognition, so it'll actually hover, get a good glimpse of whoever's in the car, send that back to the officer's cruiser so he'll know who he's dealing with before he even steps out of his car, and he can communicate through the drone. It also, because 80% of their job is traffic accidents, it'll also do all the traffic photos, videos. It'll do a scene triage, so if EMS or fire needs to be called, it'll actually take care of that through our AI technology. That's part of one of our patents as well. And it'll also do the accident measurement, so it'll do the entire accident report all by itself, so the officer doesn't have to do that. The additional thing that it also does, it'll actually drop these hockey puck IP patented flares that we design, and it'll actually drop those and start to redirect traffic for the officer as well. So again, that's a whole different part of what SpiderTech does, but we also have a fire and rescue package. We have a search and rescue package. We actually have a high surveillance package, let's say for Super Bowls or presidential visits. We have a Condor drone that will actually take off. It has I think 30 cameras. It has sensors. It has, if everybody remembers the AWACS, the big AWACS plane that had the big radio, it actually has one of those embedded into the body, but it has 3 radars in that, so it can actually track anything. So say there's an Amber Alert, you can actually launch that thing and it'll pick up that vehicle that's on the Amber Alert quicker than anything else. It'll cover 400 square miles. With that. So that's just the bigger package of why SpiderTech is kind of going to help us with the drone dominance, but having these rare minerals is critical in that, so we won't be dependent on China or any other supply chain. So sorry about that commercial, but
Go back to the patent, please.
Yes.
You said submitted. Can you explain what that means?
Well, I have a patent attorney, and he's already filed for all of our patents and all of our IPs. And then part of our research agreement with Purdue is anything that's developed together, that'll be a different kind of IP or a patent, but we've already filed for all of ours.
Okay, so all filed, nothing awarded yet.
Not yet.
Okay.
All patent pending.
So just as with this council, the state of Indiana is being much more intentional with
Sure.
some focus here on the rare earth recovery. The state's also, with our federal partners, being much more intentional as being a leader
Sure.
in drone technology. Are you plugging in with anyone at the state on that front? And if not, do you need some help with that?
I do.
Because we'd love to help you because this is so multifaceted as you're explaining it, and we want to make sure that we can connect your company to other potential points of access for the state of Indiana,
that would
especially
be
with
terrific.
the development of a drone corridor
Right.
here within the state.
Yes, sir. Any help that you could give us? I have a meeting with the IEDC next week.
Excellent.
We're working on that. I have a list of people that I've spoken to. We have our Army Lift Challenge. I believe that's in October. So we are submitting one of our drones for that Army Lift Challenge. I've already filed through the SBA, SBC, and all the other numbers. So I already have my cage code. We already have our DUNS number, our UEI. So we already have all the things that we do and registered everywhere. And then we just filed for our 45 stacks, so the 45X, 45V, that's the tax credit things, the 45Q, and then we also qualify for the 48D as well. So all those have been filed for as well. But yes, I would love any other connections you could help us with, would be great.
Any other questions or comments?
You said you're gonna put one building up for semiconductor. Have you talked to SK Hynix, because they're doing the same thing there at Purdue?
Yes, yeah, actually, they're right across from where they're making our prototype right now.
So do you need another building, or can you coordinate with them to have them produce what you need?
Well, we're not actually going to produce all of the semiconductor. It's the parts that they actually need, and so that's what they're working with us on. Because there's going to be certain parts that they're going to be sort of standing up that goes more to what they're doing, but they do have, I don't want to call them sort of side projects, but they have some side components that they're saying if they could get them right here in Indiana, they'd prefer to do that. So that's really what we're looking at for that. And then if you look at the map of our buildings, there's different buildings that are going to be in the south as opposed to the north as well. Just because, again, if we just use the rare minerals for drones, it'd take us 100+ years to try to remediate it all. But by adding some of the other facilities to it, we can really put those rare minerals to work in a lot of different ways and let Indiana truly be the backbone of the sovereign supply chain here.
My question is sort of, as a startup, what's job one and what's like aspirational year 10? Like, you're talking about these buildings.
Sure.
Like, what's priority one, I guess, to get up and going? This prototype you've talked about. I'm just trying to understand, is that what's happening first, is confirming the prototype does what you think it will do? And that's
Yes.
with the Purdue project right now in the 55
Right.
acres. near
Yeah,
the
that's the first step,
airport?
is really a proof of concept, right?
Okay.
We think the technology that we built is sound. We think the G-coding that we put together, the programming, all the software, we believe it's sound, and now it's just really proof of concept. We think the architectural build that we put together, so far, some of the mechanical parts that we've put together, those function the way that we expect them to. But now it's just, you got to test it, right? You got to do the flights, you got to see how it lands, see if the leg architecture can hold up to the weight. The lift challenge for the Army, I believe, is, I think it's 75 pounds. That it has to transport from one area, has to stay in flight for like 60 minutes. There's all these little criterias. So originally, that's what we were getting ready for, is more military stuff. But like I said, it's the same technology. We don't have to change anything on it. But because we use the same click feature that the U.S. Army uses, we can really just change out the components and make the drone into anything we want.
You've got in the back of the presentation, second to last page.
Yeah.
5-year statewide revenue projection, year one, starting at 3.5 to 4.9. What year is year one? How many years does it take to get there? How much capital does it take to get there? How much CapEx? How much OpEx? Where are you getting at 30,000 foot level?
Yep.
How do you get to year one, and when is year one?
Well, we've already applied for several grants. I have 2 grant writers. One came through the Indiana Apex group. So we just submitted for those. I just submitted for 2 the other night through the website's escaping me, but it was for one. It's for $28 million. So $7 million coming, of course, for myself, and then $21 million coming through the grant. So that's already in process as well. I have 2 others that we've qualified for. You have to submit your concept paper, and then you have to be invited. I've already been invited for 6. So I got 2 full applications already turned in. I have to get the other 4 turned in. And I'm still waiting on 4 other grants through the DOE, through DARPA, through DIU, and NSF is the other one. But so far, my concept papers that I've submitted, they've all, like I said, they've been accepted, which is huge to get through that first step. And then once we get the proof of concept, we get to skip past phase 1 and go straight to phase 2 and phase 3 for commercialization. And so we're moving rapidly ahead with that. And now with this master research agreement with Purdue, it's really speeding that up. And then they're going to also contribute now with some funding, not only helping with our prototype, but also helping with the land and getting our buildings off the ground.
What's your anticipated, this is assuming everything goes
Sure.
to plan, what's your anticipated launch date?
Well, if we go with the timeline that we had there, we should be up and running with all facilities in the next 18 to 24 months, is what I would expect. Depending on, again, supply chains with buildings and all the stuff that has to go along with that. But my builder's confident, once we get these permits and all those things done, that he can break ground by September.
So I'm sorry, going back to this?
Sure.
What is year one in your plan? Is that 2029, is it 2030?
Right, when we originally drew it out, we were targeting 28. Because again, it's going to take time to get the buildings online. Once the building's online, because we already have the drones that we're working on, I do have a meeting with the director of the state police to talk about the Never Alone package. I'm doing a ride along with the Tippecanoe sheriffs, so I can understand kind of what they do all day. So they've already given me a meeting to talk about what the Never Alone package can do for them as well. And then I also have a meeting with the fire chief in Tippecanoe to talk about the fire and rescue package. So I think, once we show them the proof of concept, that'll be our first sort of go-to-market. And then aside from that, as I mentioned before, this military competition, we feel pretty good about that. And so we expect something from the I guess it's DOW now, not DOD, DOW. And then I had a meeting with a Pentagon representative as part of the Protege Mentor Program. And so I've already done that, and they are assigning me a protege through one of the Pentagon. It's either going to be like Lockheed Martin or whoever they're going to pair me up with. But again, that's the military side of it. So I also have that sort of running parallel at the same time. So it's a civilian dual use, and then it's also the military variant. Hope that answers your question.
Thank you.
Yep.
Any other questions? All right, Mr. Phipps, thank you very
Thank
much
you.
indeed.
Appreciate the time.
Very, very good work. Thank you. Maddie, there's, I think, the final item on the agenda, additional council discussions. Do we have any additional council discussions?
If not, you better.
All right, I do want to, sure, go ahead, sir, go ahead.
Remember last time we were here, we talked about this report that Maria had put together on the rare earth elements and critical minerals in Indiana's opportunity. If any of you didn't get a chance to download it, it's at the Indiana Journal of Earth Sciences, and you can get a hold of that. Just because this report was put together doesn't mean that research has stopped. And so Maria's doing some things right now, and if we could pass these out. Maria, could you come up and go over some of the things that you're doing right at the moment?
Yeah, we are not on the agenda, so I am going to be very brief and tell you what projects we are working on currently and what we would like to work in the future. So on that one page, what you have, it's current externally funded projects, and I put 3 of them, and one that we are looking at critical minerals in marine shales, Pennsylvania shales that are associated with coals. We had a project already that we just finished for 3 years, and the big report is available from USGS as well as from Indiana Geological and Water Survey. And these are the shales that they don't have that much rare earth elements, but they have a lot of metals. Other critical minerals such as vanadium, such as arsenic, such as lead. And we did characterization of that, and their concentration is often 10 more times than average. So we are going into 4,000 sometimes ppm of concentration. So a huge resource could be a huge resource for those other elements. And we, as a result of that project, we got 3-year additional project to go into more detailed characterization within Indiana specifically, because the first project was kind of Midwest, so it's collaboration with other states around us. So this one that we will run till 2029, just to go into more detailed characterization and really calculating the resource, how much we have in those rocks. And then also another project also supported by United States Geological Survey, it's critical minerals in the Devonian shales. Devonian shales, these are that we have in sequence below the coals, and they don't have that much critical minerals like Pennsylvania shales, those above, but obviously Devonian shales are much thicker, so as a result, something for lower concentration but higher thickness also give us quite a bit of resource. So again, this is a project that we will end first 3 years in next year, 2027. Another project that we have coming very soon, it's phase 2 or CORE-CM. You probably heard about CORE-CM1, that we had funding for 3 years to look at critical minerals and specifically rare earth elements in coal waste. So as a result of that, we generated a lot of data on coal tailings, some gobs, some coal ash, and we have that published through Indiana Geological and Water Survey, and also summarized in that report that Todd probably has with him today. So in a phase 2, we are just going to expand that research and evaluate additional gob deposits, additional coal tailing deposits, get also more analysis of coal ash, and we also want to look at the to look at brines as potential sources of lithium and other critical minerals. And here we need to work together. I don't have drones, and now I know somebody who has drones. I think we can help. You can help us. We can help you with some of these. And we have several proposals pending. Yeah, I probably shouldn't take too much about these projects because we have some hope that we'll get them, but we don't have them yet. But at least it gives you idea what kind of direction we want to take it, what we want to work in the future. So the first project that I mentioned under proposals pending, this is collaboration with Argonne National Lab and Peabody Energy Corporation. That's integrated process for recovering critical minerals from coal tailings optimized by X-ray scattering. What we really want to do here, we really want to improve this initial pre-concentration from our sources, specifically from coal tailings, that we can kind of monitor on site in real time and see how we can improve the current processes. And maybe if it works on lab scale, we can take it to a preparation plant, and Peabody Energy is our collaborator on that one. Second project is a collaboration with Purdue University and Miron plant, which is Hallador Energy these days. Coal wastewater treatment with reverse osmosis. This is kind of new techniques to look and treat the waters that come from power plants or kind of liquids that we want to clean them before we either put them underground or use for other sources. Number 3 on that is on that list is Genesis mission. And you probably have heard about that. This is in response to this $300 million that the government came up with recently and said that that they want energy-related and critical mineral-related projects aided by artificial intelligence, so AI related. So we have a project pending there, proposal AI-enabled resource characterization and process-relevant mapping of rare earth elements and critical minerals in coal mine refuse. And this is, we are the leading institution here, IMPI. This is collaboration between Indiana University and then Southern Illinois University, Michigan Technological University, Fairfield University, and Argonne. So there are several of us. This is, we applied for phase 1, which is 9 months. And then if in this project, after 6 months, if DOE decided that project is continuing, we can apply for phase 2. And phase 2, we are talking about 4 next years and up to 16 million. But that's, again, is still within my hope only at this point. And the last thing that I want to mention, that we have a little project that we have hope to have funding from Indiana University, looking at clays in Indiana as a source of rare elements and nanotubes. And so that's the kind of critical mineral research at the survey that we worked in the past, we working currently, and we hope to continue this kind of research. So if you need any help, in terms of characterization, in terms of location, in terms of mapping, we are there for you as your resource. But I like your drones. Thank you.
Anything else from anyone?
Oh, me again. So right at the end of the last meeting, we approved this executive summary here. And number 5 said we didn't get to this because we ran out of time. It said create a subcommittee dedicated to evaluating pathways for obtaining degrees regarding the geological studies. And those of us that are in the geology field realize right now that we're dying. We don't have any geologists. We have hardly anybody taking classes or doing anything with that. I think it's just a change in society right now. Kids don't spend time outside. You know, they don't like to get dirty or anything like that. But the AGI had put a report together to talk about where we are with geologists. And I want us to turn over to this covers a lot of the different fields that are in the earth sciences. And if we can turn over to the last paragraph, I think it's pretty dramatic. We're sticking together on that. So in this last paragraph at the end, it says, based on age demographics of the current geosciences workforce as identified by the Bureau of Labor Statistics, with an average retirement age of 65, then 27% of the existing geoscience workforce will be retired by 2029. The number of geoscience graduates entering the workforce each year will not be sufficient to fill the gap created by the requirements, and an additional 22,000 new jobs are projected to be created in the profession by 2029. As a result, by 2029, we're going to be 130,000 geologists short of what we need in our country. And AGI is looking at it from the standpoint of at the college level. I think it's really different. I think we got to start lower. You know, we got to get down into the high schools and into the elementary schools. Unfortunately, here in Indiana and a lot of states, once you get out of elementary school, no earth science is taught anymore. You know, so by the time you get into middle school or you get into high school, there's no field. I mean, there's nobody pushing anybody to move you into that type of direction. And I think that's something that we really need to think about here in the state of Indiana, because as you can tell from what Maria is talking about, we got a lot of stuff, we got a lot of rare earth elements and other things in our rocks and our sediments. And if we don't have those people out there doing that work to find it for us, we're not gonna have it. You know, so anyways, I don't know where we want to go with this subcommittee, because I'm one of that 27%. In 2 months, I'm going to retire. So I've worked at the Geological Survey for over 40 years now, and I'm going to be retiring from there. So I don't know where we're going to go with this subcommittee on that. And also, if this board wants to continue to have the Geological Survey as part of it, I would recommend adding Maria in my position because of her knowledge of everything, you know, related to the materials we have here in the state of Indiana. So that's all I have to say.
Well, we'll have Maddie take that down. As an old university administrator, I will continue to say what I said when I used to be at Indiana State University. If you are a chair of an academic department, you are responsible for your enrollment growth. And unfortunately, we do not have enough academic department chairs, including in the area of geology, that are getting out there hustling, inspiring young people to enter into some of these important, highly critical professions that are good paying jobs and mostly needed. And we got a lot of empty seats at a lot of universities that the taxpayers are funding. So in part, it's the state using a little bit of tough love to our public universities to say, we believe in you, and we expect you to help grow your particular departments. But I couldn't agree with you more. We've got to inspire our young people to enter into some of these incredibly important and exciting fields, but there continues to be a disconnect between the K through 12 world and higher education. I want to thank the Fort Harrison State Park and our incredible team with DNR and the leadership of Director Morrison and Secretary Jaworowski, and I think we have concluded our business. Thank you very much.